Okay, SpongeBob Challenge 1.1 will be simplifying using the operators, and we're simplifying integers. So let's talk about a couple rules I use. The rule is same signs add, different signs subtract, bigger sign wins. Again, same signs add, same sign add, same sign add, and different signs subtract. And then last, bigger sign wins. Okay, so right here we have a positive 4, a positive 7. Those are same signs. So same signs, when we collect, those are going to add. So 7 plus 4 is 11. The bigger number is 7, and its sign is positive. So that means that the bigger sign from these two numbers, which belongs to the 7, is positive. So it's a positive 11. Bigger sign wins. Here I have a negative 4 and negative 7. These are also same signs. Same signs you add. So 4 plus 7 is 11. Now, 7 is the bigger number, so his sign wins. So this is going to end up being a negative 11. Here we have different signs. One is negative, one is positive. If it's different signs, we're going to subtract. So 7 take away 4 is 3. Furthermore, the bigger sign wins. 7 is bigger, and his sign wins. So that's going to be a positive 3. Here we have different signs. A positive 4, negative 7. Different signs. So we're going to subtract. So 7 take away 4 is 3. The bigger sign is going to win. So 7 is the bigger, so his sign is going to win. So it's going to be a negative 3. Okay. So those are our rules. Same signs add, different signs subtract, bigger sign wins. Now we have multiple integers here. First thing we're going to look for is the same signs. I usually look for negative same signs first. So we have a negative 1, a negative 4, and a negative 9. Those are all same signs. So all is going to add. Same signs add. So 1 and the 4 and the 9 is going to become a 14 when you add them together. And the bigger sign wins, which they all are negative. So everybody wins. Now, we're going to put together all the positives. Those are the same signs. The 5 and the 8 are both positive. So we're going to add those together. Same signs add, and we'll get a 13. And the bigger sign for the 5 and the 8 wins. It's 13. So we put these three together, and then we put those two together. Now we're down to just two, a negative and a positive. These are different signs. Different signs are going to subtract. So 14 take away 13 is 1. And now the bigger sign should win. So 14 is the bigger, and its sign is negative. So the answer should be negative. Negative 1. Okay. Here, putting together all my negatives. I have a negative 1, a negative 9, and a negative 8. Those are all negatives. So same signs will add. So when I add all these, I'm going to get a 18. In particular, this is going to be a negative 18 because we added all negatives. So remember, bigger sign wins. So everything's negative. So, but the negative 9 actually wins. So then we're going to put all our positives together. Now that we've got all our negatives together. And the 4 and 5, they're both the same sign. They're both positive, so they add together to become a 9. Okay, and that's a positive 9. So the bigger sign wins. Now, here I have a negative and a positive. These are different signs. Different signs subtract. So 18 take away 9 is 9. And remember, the bigger sign wins. The 18 is the bigger number, and its sign is negative. So the answer will be negative. Oh. On my cloth. Okay, let's take a look at the next ones. Number 3. Okay, now we're dealing with double signs. Whenever you have double signs, we're going to convert those to a single sign before we start our process. Whenever you have negative, negative, that converts into a positive. Whenever you have a positive, negative, or a negative, positive, both of these convert into a negative. And should you ever have a positive, positive, that converts into a positive. So we're trying to turn two signs here into one single sign, kind of simplifying all the signs. So rather than having two, we're going to have one. So let's find all the double signs, convert them to one single sign, and then we'll start putting our operations together, our integers together. So that's a positive, positive. Sorry, that's a negative, negative. Now become positive 2. I don't have to put the positive up front, but I'll do it anyway. Here you have a positive, negative. That combination is negative, so one single negative and 5. Here, negative, negative, so that combination is one single positive and 2. So once again, converting all the double negatives first into single negatives, and then we start our process of putting things together. All right, so all our negatives, oh, we only have one negative, so that's negative 5. Okay, now all our positives. We have a positive 2 here and a positive 2 there. Same signs, add. So we'll get 4. Bigger sign wins, so that's positive 4. Okay, from here we have different signs, a negative and a positive. Different signs subtract. So 5 take away 4 is going to be 1. The bigger sign is going to win. 5 is bigger, so its sign wins. So that's going to be a negative 1. Next, number 2. Here, there's only one sign here, which is great. So there's nothing to change there. Here, we have a positive negative combination. So we're going to make that into a negative, single negative. This is a negative negative combination. We're going to turn it into a single positive. This is another negative negative combination. We're going to turn it into a single positive. Okay. So now I'm going to work on combining all my negatives together because same signs add. I have a negative 1 and a negative 2. Those are combined. It's going to add together to become a 3. The bigger sign, of course, wins, so it's negative 3. So negative 2 and negative 1 become negative 3. Our positives are the 5 and the 2. They're going to add together and become a 7. In particular, positive 7. Okay. Now I have different signs. I have a negative 3 and a positive 7. Okay. So different signs are going to subtract. So 7 take away 3 is going to be 4. We're going to subtract. And the bigger sign is going to win at the end. The 7 is the bigger number and its sign is positive. Therefore, the answer is going to be positive 4. Okay. That's it. Okay. Let's take a look at the next problems. Oh, expanding and simplifying. Okay. For years, I've been teaching for over a quarter of a century. For years, I've given these problems to students at the beginning of class and say, hey, you guys, work on these and see what you get. So they would work on them, and typically they would get about half of these wrong. And I know what they were doing because they were assuming some things about the negatives and positives. And this gave me an opportunity to show them if you write out the problem or expand it, you can actually see why the answer is what it is. Some thought some of these answers should have been negative, some thought some should have been positive when they worked it out, and they found out when I solved it, it was a completely different answer. But again, once I show you the expansion, the answer, whether it's negative or positive, suddenly makes sense. Okay, the expansion of 3 to the second power is this. It's 3 times 3. Then the product of 3 times 3, that gives you 9. So that's finished. Okay. Here we have a negative and a 3 to the second power. The first step here is that we're going to convert that negative there. Okay, that's the first thing we're going to do. Convert the negative, nothing else. We're going to convert the negative to a negative 1. And 3 to the second power. Okay. So again, the negative has been converted to a number, a negative 1 in its own parentheses. Then the next step, we're going to expand the 3 as we did before. So this is really representing a negative 1 times a 3 times a 3. And now that you see it as a negative 1 times a 3 times a 3, it makes sense why it would be a negative 9. Most students make that into a positive 9 because they think the square is activating on the negative. The negative really represents a negative 1. So once you write it out as a negative 1, it makes sense why why you don't have a positive answer at the end. Okay. Now, negatives on the exponents is different. Negatives up front, how to get rid of those, we convert those to negative 1s. When we want to get rid of a negative on the exponent, what we do, the rule for that is take the reciprocal of the base. So this is the base 3. The reciprocal of the 3 is 1/3. So once you've taken the reciprocal, that's when the negative goes. And so now it's just a 2. Okay. Once you get it to a positive integer, 2, then you can start expanding. So let's expand this. It's 1/3 times 1/3. That's the expansion of the second power. And then 1/3 times 1/3. When you multiply fractions, you multiply numerators and you get 1. Then multiply denominators and you get 9. So again, once you see the expansion, it makes sense why the answer is what it is. Okay, number 8, we have 2 negatives to deal with. A leading negative here and a negative in the exponent spot. So we'll deal with both negatives one at a time. The first negative we deal with, again, is this negative here. So I'm going to convert that to a negative 1. Okay. And also I want to remind you, on these problems, you do just as I do. So I'm grading the first column, which are these problems right here, on whether you're recording what I'm doing exactly the same. Not whether it's right or not, because I'm showing you how to do it the right way. But I'm checking out your recording skills and marking where you're having trouble recording what you're seeing. So this is my chance to kind of clean up your ability to record lessons. Okay, so the first step is negative 1 times 3 to the negative second power. Now I'm going to deal with this negative 2 up here. So this is still negative 1. Take the reciprocal of the 3, which is 1/3, and now it's a positive 2. Okay, so I'm dealing with the negative step by step. First, this negative, we handle that, and we convert that to a negative 1. Next, once here, we convert this negative here to a reciprocal of the base, and now it's gone. Now I'm going to expand. Okay, so that's the expansion. This is a negative 1 times a 1/3 times a 1/3. And once you look at the expansion, it makes sense why the answer would be a negative 1/9. Okay. All right, number 9. Number 9, we have negatives again. We have negative here and a negative here. But this negative is inaccessible or inaccessible. That's because it's in the parentheses. The parentheses is keeping us from converting that to a negative 1, as we did with this one and this one. Oh, yeah, this one and this one. So that means we can't start with this negative. It's protected. We have to deal with this negative here. So when we remove the negative from the exponent, we will get a reciprocal of the base. And there's a reciprocal. Negative 1/3. Okay. The negative's still inside there, nice and protected. Now, let's expand that. We have a positive exponent. We can expand this into negative 1/3 times negative 1/3. Okay. And so from the expansion, it makes sense that the answer would be a positive 1/9. There we go. So we want to not work from this. Most of my students, they try to look at the problem, assume the answer, and they write down the answer. They want to do it from all viewing this. But once you take time to write the steps down and you look at this as the source of how you're going to answer, you're most likely going to get it right, because the expansion has way more details why the answer is what it is than just staring at the original problem and kind of guessing through your head. Okay, last one. We have 3 negatives to deal with. Negative here, here, and here. This negative right here, since it's on the outside, can be converted to a -1. Next, this negative is still inaccessible, so we go to this negative right here. To remove this negative, to become a positive, or should I say, to convert it to a positive, we have to take the reciprocal of the base. And there we go. There's a reciprocal of the base, and now the 2 is positive. Now that my 2 is positive, I can use expansion now. So this becomes -1 and -1/3 and -1/3. And again, once you write out all the steps, get to your final expansion, it makes sense why the answer would be what it is. This would be a -1/9. You're multiplying by 3 negatives, so that's negative. And the 1 times 1/3 times 1/3 is your 1/9.